Hey, Pre-Cal. I hope you had some good practice with slopes. We're going to talk a little bit more about slopes, and I tell you about perpendicular and parallel lines to start off with. And then we're going to move into a section called equations of a line, or the equation of a line. There's three parts to that. I don't know how they'll be divided into videos, but we're going to look at slope-intercept form today. But let's start with slope. So to understand it a little bit better, it's good to have a picture of what we're working with. In this case here, I've drawn one graph, and there are two lines on that one graph. And I'm going to say that these two lines are parallel. Now, what parallel means is that these two lines will go on forever and never touch. It's tragic. Now, what do the slopes have in common? Some of you might be able to identify that just by looking, but I'm going to write down the equations for these lines down. So there are equations that represent each of these lines, and you'll notice something very special about the slope. Ta-da! So here are our equations of the lines. For the brownish orange one, you've got y equals 1x plus 2, or just y equals x plus 2. And for the green line, we have y equals 1x minus 2, or y equals x minus 2. Now, if you don't know where those equations come from, that's okay. That's what these next three topics are going to teach you. But first, recognize that the slope in both of these cases is 1. And that's the thing with parallel lines. If you have parallel lines, the slopes will be identical. Okay, I'll set that there as a note for you. We're also going to look at what a perpendicular line could be. All right, the second example is when you have two perpendicular lines. So I've used the green one again, y equals x minus 2, or y equals 1x minus 2. And just remember, whenever you have a number by itself, so the slope in this case is just a 1, it can also be written as a fraction over 1. Okay, so it's 1 over 1x minus 2. 1 over 1 is just 1, right? The other line here is a perpendicular line. That's the orange one. And unlike a parallel line, in a sense, it tries to meet the other line as fast as possible. So parallel lines, they never meet, ever. But perpendicular lines, as soon as they can possibly cross, they will. They also create 90-degree angles between them. So every single one of these parts where there's a bisection, all of those are 90-degree angles. You can only get those when you have two perpendicular lines. So what does the equation for the orange line look like? Well, it becomes y equals negative 1 over 1x plus 0. Does that really teach you anything? Well, there's a few parts to it. The first thing is that standalone value at the very end, the 0 in this case and the negative 2 in the green line, they can be whatever you want them to be. They don't actually matter in this case. What does matter is the slope. And you might recognize that this slope is the inverse of the slope that we had before. So your fraction, you always want to deal with fractions, ends up flipping, and then you turn it into a negative. I'm going to show you another example so that we can work through something that's a little bit more different than just once. Let's take a look at that. But first, the definition. Perpendicular lines, the slope is going to be the negative reciprocal of the other line. Did I lose you a little bit there? The word's a little bit awkward. Let's look through another example and hopefully we can work through that a little bit better. Okay, so in this example, I apologize, there's supposed to be parallel lines, but because I'm freehanding this, it's not quite right. Pretend they're parallel though, please, for the sake of the example. Because they're parallel, their slopes should be identical. That's what we're looking for. And that's true. If you look at the slope value, 1/2 for both of them. And keep in mind, we haven't learned about what the slope value is in an equation yet, so if this is throwing you off a little bit, that's okay. I just wanted to build towards that in our next video. But yeah, that value attached to the x in this case is our slope, and it's the same for both lines because they are parallel. Now watch what happens to the equation of a line when I draw the perpendicular one to both of these lines here. Okay, so we've added this orange line, which is our perpendicular line, and the equation is up at the top here. Y equals minus 2 over 1 times x minus 1. Now the slope, as I mentioned, is attached to the x value, so that's right over here. And you'll notice that it is a negative reciprocal. Negative, so I just put a negative sign in front of it. If one of these are already negative, it'd be a double negative. And reciprocal, I just flipped my fraction over. So I had 1 over 2, now I have 2 over 1. I had positive 1 over 2, now I have negative 2 over 1. That's how you can determine a negative reciprocal. That's how you can determine the equation of a perpendicular line. So in your practice, when you're asked to determine, say, a perpendicular line, you can write any equation you want, provided you have the same slope. If you're asked to give a perpendicular line, you'll have to flip your fraction over for your slope and then make it negative.